In this video, I'm going to look at an example of an if in Excel. The data, the spreadsheet Excel file is available at the site seen here, at the URL seen here, and this between the does and the it and the float are underscores, so you can sort of see appear in the title of the file. So in the data, it gives the mass and it just assumes a simple sort of length, width, height kind of shape, a rectangular sort of a shape, three-dimensional rectangular shape. Can't think of the right word for that. In centimeters, and gives the mass of the object in grams, and then we will calculate its density. And then we'll be asking a question about the density and making a comparison to the density. First, we'll just assume that it's water, pure water. Then maybe we'll introduce some other kind of fluid with a different density. And then first we'll just say, does it float or not? So just we'll expect the output to be some words. And then ultimately we'll try to do maybe some other calculation to say that we can get more out of the output of the if than just words. Okay, so I'm going to calculate the density. So we can do it in steps, or we can do it all at once. So we can say it's the mass divided by the volume, and the volume is the length, width, height. So I can break it up into steps and calculate the volume, and then do mass over volume. So I can break it down, or I can do it in one step. I'll do it in one step just because that will raise an issue that I'd like to talk about briefly. So this is the density will be grams over centimeters cubed. Let me take that 3 and make it a superscript. Okay. And okay, so this is going to be equal to the mass divided by the length times the width times the height. So I'm going to do it wrong, and then I'm going to fix it. So this is wrong. So what I did here was I did the length divided by just the mass divided by just the length. And after I got that, then I multiplied by the width and the height. But I want the width and the height to be part of the volume and in the denominator. And that's why this is wrong. So some people think that the slash means here's the overall numerator and here's the overall denominator, but that's not the way it works. Multiplication and division have the same order of operations, the same precedence. And so we just sort of start evaluating from left to right. So this A2 divided by B2 is a division, but then the C2 and the D2, that occurs afterward. So it's just this occurs, then that occurs, and that occurs. If we want the whole multiplication to occur before the division, then we must put in parentheses. So now that is a proper density, sort of all the mass divided by the full volume, length times width times height. Okay, it's just a mistake a lot of people make, assuming that the slash means more than does. The slash means division, but it doesn't break up a full numerator and a full denominator. There's an order of operations that is respected. And so if you want that whole multiplication to happen first, then you must force that by parentheses. So now I have the mass divided by the full volume, length times width times height. And I can now come in and get what I would call the thin cross and the fill cursor. And then I can either drag down or double click and copy down. And that just updates my formula as I go for so now I'm in row 5, and it's the mass in row 5 divided by the whole quantity of the length and the width and the height from row 5. Okay, so these are the densities, and some of them are above 1 and some of them below 1, and that's where the question of floating comes in, because we're going to compare it to the density of pure water, which is 1 gram per centimeter cubed. So let's just say that here, float in water, question mark. And we put a border around that, okay. And so I'm just going to say equal if, and if the density, and I'm going to compare it to 1, if the density is greater than 1, then I will say that it will sink. I'm just going to have words, and words are, the fancy term will be literal strings, and literal strings will go in quotation marks. So I have in an if, I have 3 things. I have first the condition, the test I'm going to do, some true or false question. So I'm asking, is the density greater than 1? That's either true or false. If it is true, it's not in this particular row, but if it were true, then I'm going to say that the density of the object is bigger than the density of water and the object will sink. Otherwise, I will say float. So it is question what to do if it's true, what to do if it's false. And what I want to do in this case is just write a word, sink or float. And so when the density was less than 1, it floated. When it was more than 1, it would sink. And so there we go. So that was just our simple if. Now I'm going to make it just slightly fancier. I'm going to insert a column up here, and I'm going to have some, maybe I'll do one more. And I will have some fluid density. It may, I didn't spell that right, density in grams per centimeter cubed. And I'm going to assume that I have something other than waters and fluids. And so maybe it's a less dense 0.95. So whatever fluid this is, it's somewhat less dense than water. And now, and then we'll say float in, I don't know, above fluid. Now this is getting too long. I think I will right click and format these cells and under alignment tab say wrap. Okay, that's a little bit better. Okay. And now I'm going to do sort of the same question as here, except I'm going to compare it to this density rather than just explicitly typing in a 1. So again, equal if the logical test is if, how does the density of the object is greater than the density of this fluid. Again, I want to say sink or float. But now, if I want, as I copy down, I want E4 to turn into E5 and so on. But I want G to always stay G1. So I need to put a $sign here since I'm copying down. The $sign will make it when I copy down that it that the 1 doesn't change, doesn't. So the 4, the E4, the 4 will change as I copy down. The 1 will not change because the $sign in front of it. I could do $sign G, $1. I'm only going to copy down, so that's a little bit of overkill in this case, but I could do it. So if I put a $sign in front of the G, that means that I can copy horizontally as well, and that it won't change. So I don't need that here, so I will just drag down And there are a few cases here. This case that floated in water, but will sink because it was less than 1, but more than 0.95. Okay. So that's just a way to introduce a cell with some absolute addressing, $sign. Now I want to show next that I can do something else with other than just put words down here with my ifs. I can calculate, I can do some calculating and change my calculation based on the output. So I'm going to calculate something called the buoyant force. So this is the fluid will push up on the object, and if the object floats, the push up is going to be exactly equal to the weight. It's just going to find a location where there's enough of a buoyant force to balance the weight. But so that's the float. But if it sinks, then it's just the the fluid does as much as it can, but it can't overcome the weight, and that's why it sinks. Okay, so the question is the same question, just what we're going to do is going to change. So the logical test is still the density greater than, let's do the fancy one with the fluid. Let's put in our $sign. And then the first one was it sinking. So now the density is greater than the fluid, so it's going to sink. And so then the buoyant force is going to be, so the whole object's going to be underwater. And so we talk about the volume displaced. So the whole object is underwater, so its whole volume is the volume displaced. And so the calculation of the buoyant force then is the density of the fluid, G $1, times the acceleration due to gravity. I'm just going to put in a 9.8. And then the volume displaced, which is the full volume. So that'll be the B, the width, the length times the width times the height. Okay, so it's just some calculation, something as far as, I just want to show that we can have something here other than words. So this is a calculation based on if the density of the object is greater, if it's going to sink, then the whole volume is going to displace. And then this is the weight of the water displaced. So the density of the water times the volume of the water will give me the mass of the water times 9.8 will give me the weight of the water displaced. Okay. Now, if the object floats, the object's going to sit on the top of the water, and it's not going to be the full volume displacing, but it will displace just enough to balance the mass. So it's going to be equal. The buoyant force in that case is going to be equal to the weight. So in that case, it's just going to be the mass times the 9.8. And then I have to think about what units I'm in. I'm multiplying grams. It's like grams times meters per second squared. So I'm not sure what my units are here. If I want newtons, I better divide by 1,000. So maybe I'll come and do that. If I want my answer in newtons, I'll convert my masses from grams to kilograms by dividing by 1,000. And that's like the normal unit. Okay. So this is now the buoyant force in newtons. But my point here is not all that crazy physics. My point here is that in this case, I was asking a question And what I was doing, true or false, was words. And what I was doing here was the same question effectively, but using that true and false locations to do some calculation. And that's basically what I'm going to show you. Just another example of ifs in Excel. You have the if function, you have the three parts, the three arguments, the true or false question, what you want to do if it's true, what you want to do if it's false. It can be simple literal strings, or it can be calculations. That's what I wanted to show you. Thanks for your attention.